Okay, so in this lesson we're going to learn how to solve a system of equations using the elimination method. This is a continuation of the previous two sections where we are studying how to solve system of equations. So this will just be the same kind of problems we were doing previously, just another technique that we can use to solve it. Before we get started, I want to talk about this rule called the addition principle of equations, which states that if A is equal to B and C is equal to D, then A plus C has to equal B plus D. And so what we're doing there is we're taking these two equations, A equals B and C equals D, and I know they might look like just two letters that are equal to each other, but they are representing any kind of equation. A is just the left-hand side of the first equation, and B is just the right-hand side. So for example, A could be representing the x plus y that you see down there in the first example, and B could represent 9. So it's just the left and right-hand side of some equation. C equals D, that just represents the left and right-hand side of some second equation. And we can add those two sides together. We can add the left-hand sides together, and we can add the right-hand sides together. And so if we add the left-hand sides together, we get A plus C. If we add the right-hand sides together, we get B plus D. And this addition principle tells us that those results must be equal to each other. So let's use this principle for solving a system of equations. All right, so let's take these two equations here in this first example. We have x plus y is equal to 9. That's one equation. We have 2x minus y is equal to negative 3. That's a second equation. Let's apply the addition principle of equations to this system of equations and see what we get. So we'll add the left-hand sides together and we'll add the right-hand sides together. When we add the left-hand sides together, we get x plus 2x, which will be 3x. The y minus y cancels out, so the y variable just completely gets eliminated. And on the right-hand side, we get 9 plus negative 3, which will be 6. And the addition principle for equations tells us that those results must be equal to each other. So we end up getting 3x is equal to 6. With the y variable out of the picture, we can now solve this equation for x, and we will do so by dividing 3 from both sides, and we get x is equal to 2. All right, so we find half of our solution to the system of equations. To find the other half, the y value, we have to take x equals 2 and plug this into one of our two original equations. And it doesn't matter which one you use, you'll get the same answer for y with either equation. So we'll use the equation that looks easier, which I think we can all agree is the top equation. So we'll take x equals 2, we'll plug it into the top equation, and we will get that 2 plus y is equal to 9. Subtracting 2 from both sides gives us y equals 2. And I think it's off the screen here. Hold on one second. Let me show. Okay, there it is. Okay, subtract 2 from both sides. And I said y equals 2. What was I saying? We get y is equal to 7. All right, so when we plug in x equals 2 and solve for y, we get y is equal to 7. All right, so let's see. I apologize for this. And so putting those two solutions together, we can write them as an ordered pair. We put the x value first, so we get 2, and then the y value second, so we get 7. 2 comma 7 is the solution to the system of equations. So we can use this addition principle for equations to solve a system of equations. The only requirement for this to work is that one of the variables needs to be eliminated when we use it. Hence the name elimination method. All right, so let's try another example. Let's look at 2x plus 3y is equal to negative 9. And 5x minus 6y is also equal to negative 9. So here we have a system of equations. If we try to do what we did in the last example and just apply the addition property of equations to this example, the way it's given to us, I like to say right out of the box. So if we apply this addition principle to this system of equations right out of the box, what we'll end up getting is this. We'll get 5x plus 2x, sorry, I'm saying it backwards. We get 2x plus 5x, which gives us 7x. We get 3y minus 6y, which gives us negative 3y. And on the right-hand side, we get negative 9 plus negative 9, which is negative 18. And the addition property tells us, the addition principle tells us that these have to be equal to each other. So we get 7x minus 3y is equal to negative 18. And so this has to be true, but while it's true, it's not very helpful. So it is true that if 2x plus 3y is equal to negative 9 and 5x minus 6y is equal to negative 9, it's also true that 7x minus 3y is equal to negative 18. So it's a true equation, but it doesn't get us any closer to finding the solution to the system of equations. And so if you stop and think for a moment, you might come to this realization. If only this 3 were a 6, everything would have worked out great. We would have had 6y minus 6y, and the y's would have been canceled out. And that's exactly what helped us in the last example. And so instead of wishing for this, let's make it happen. Right? So let's make it a 6, but we have to do it mathematically. We can't just erase the 3 and write a 6 in there. How can we make this 3 into a 6? We can multiply the top equation by 2. By multiplying the top equation by 2, and when I say multiplying the equation by 2, I mean multiply the left-hand side by 2 and multiply the right-hand side by 2, we can get a 6 there in front of that y, because we'll get 2 times 3, which is 6. So distribute a 2 to both sides of the equation, and what we end up getting for the top equation is we get 4x plus 6y is equal to negative 18. The bottom equation we're not going to do anything to at all. We'll just copy it down beneath the first equation, and now we have a 6 there. So instead of wishing for a 6, we are going to make a 6 there by using math. And now we can add the two equations together. We'll get 9x on the left-hand side. The y's cancel out. On the right-hand side, we'll get negative 27. And the addition principle tells us that these have to be equal to each other. So we get 9x is equal to negative 27. And now we can solve this for x with y out of the picture. So let's go ahead and divide 9 on both sides. We get x is equal to negative 3. Just like we did in the last example, we have to find the corresponding value for y. We'll plug this value, x equals negative 3, into one of these two equations. And so I'm going to plug it into the top equation before I multiplied it by 2. So we could plug it back into one of the two red equations, but those numbers are a little bit bigger than they really have to be. So I'm going to go back to our original equation set and plug negative 3 into whichever one of those two equations looks easier. And I think the top one looks easier. Before I multiplied it by 2, we have smaller numbers. It just seems like a more friendly equation. So I'm going to take this 2x plus 3y equals negative 9. I'll plug negative 3 in for x. And so we'll get 2 times negative 3 plus 3y equals negative 9. 2 times negative 3 is negative 6. We'll add the negative 6 to the other side, and that gives us 3y equals negative 3. And then we'll divide by 3 on both sides, and we get y is equal to negative 1. So putting that together, we have x equals negative 3 and y equals negative 1. So as an ordered pair, our final answer is negative 3 comma negative 1. All right, so that's essentially how the elimination method works. We will most often have to do a little prep work to get a variable to cancel out. Sometimes it just requires multiplying a number to one equation. Sometimes it will require multiplying numbers to both equations so that the variables will at least one variable will cancel out, and then we can solve for the other variable. All right, let's take a look at another example. We have 3x minus 2y is equal to 1. We have negative 6x plus 4y is equal to negative 2. So the first thing we have to decide is, well, which variable do we want to try to eliminate? And so I think let's try to make the y variables cancel out. And so again, our wishful thinking is if only that was a 4 there. If we had 3x minus 4y equals something, then the y's would cancel out. But instead of wishing for a 4 there, let's go ahead and make a 4 there. And we can accomplish this by multiplying the top equation by 2. And that's going to give us a minus 4y on top, and we'll have the plus 4y on the bottom equation. The y variables will cancel out when we do that. So multiplying the top equation by 2, we distribute. So we multiply the 2 to the 3x, and we get 6x. We multiply the 2 to the negative 2y, we get minus 4y. And we multiply the 2 to the right-hand side, and we get 1 times 2, which gives us 2. The bottom equation, we're just going to leave the way it was to begin with. We're not going to make any changes to it. And now we'll go ahead and add these two equations together because we know the y variable is ready to be canceled out. So let's add the left-hand sides together. But when we do this, we find that not only the y variable cancels out, we find the x variable gets canceled out as well. And so everything gets eliminated from the left-hand side. So this was unintentional. Our intention was to cancel out the y variable, but the x variable goes along with it. And so we get nothing on the left-hand side, which we represent with the number 0. On the right-hand side, we also end up getting 0. We get 2 minus 2, which also gives us 0. And so our final result here is that 0 is equal to 0. This is always true, which means that we have a dependent system. We have an infinite number of solutions. So if this had come out false, we would have an inconsistent system with no solution. But because it comes out true, we have an infinite number of solutions, which makes it dependent. It's still consistent because there are solutions to the equation. Right. So how do we write our solution set when it's a dependent system? We use the set notation. And we're going to say it's any x comma y such that, and we just write one of the equations in there, such that 3x minus 2y is equal to 1. And so again, there's an infinite number of solutions, but that doesn't mean that any ordered pair is a solution to the equation. For example, 0 comma 0 is still not a solution to this system because it doesn't satisfy either one of the equations. So while there's an infinite number of solutions, it's not anything that you want. And so we have to specify what actually works. And by saying the set notation, any x comma y that satisfies the equation, 3x minus 2y is equal to 1, that is a good way to represent the solution set there. But it's a dependent system. Let's look at another example. We have 5x plus 3y is equal to 25. We have also 3x plus 4y is equal to 26. And we want to solve the system of equations using the elimination method. To eliminate one of these variables is going to be a little bit tricky because we might look at this and say, oh, if only we had a 4 here instead of a 3, then we could get these equations to cancel out. But we can't really make a 3 into a 4 very easily. So there's no number I could multiply to this equation so that when it gets multiplied to the 3, it becomes a 4. We can multiply it by something to make it a 6. We can multiply by 2 to make it a 6. We can multiply by 3 to make it a 9. So we can work with multiples of 3. But turning that 3 into a 4, that's going to be tough to do. So what do we want to make it into? Well, we're going to go for 12 because we can make the top equation have a 12 in front of the y by multiplying by 4. But we'll also have to multiply something to the bottom equation to also turn it into a 12. It's very similar to finding a common denominator. So given that we have a 3 and a 4 here, what's a common number that both of them could be multiplied to? 12 would work, right? We could multiply the 3 up to a 12. We could multiply the 4 up to a 12. And so we're going to get both of these to equal 12 in order to get the variable to cancel out. So we'll multiply the top equation by 4 to make that term in front of the y a 12. And we'll multiply the bottom equation by negative 3 to make that into a 12. And the reason we want to multiply by negative is not only do the numbers need to be the same, they both need to be 12, but one needs to be positive and one needs to be negative in order for the variable to get canceled out. So we're going to make that bottom one into a negative 12 instead of a positive 12. So we multiply 4 to the top equation. We're going to get 20x plus 12y equals 100. Right? Make sure you multiply the 4 to every term on the left and right hand side. To the bottom equation, we're going to multiply negative 3. So we're going to end up getting negative 9x minus 12y equals negative 78. Make sure you multiply the negative 3 to every term on the left and right hand side. Now we'll add these equations together. And what's going to happen is we'll get 20x minus 9x, which will be 11x. The y variables are going to cancel out. We made sure of that. And then on the right-hand side, we'll get 100 minus 78, which is 22. So we end up with the equation 11x equals 22. We'll divide by 11 on both sides, and that's going to give me x equals 2. Now that I know what x is equal to, I can find the corresponding value for y. I just plug this value of x into one of my original equations. Again, I'm going to go back to the equations before I multiplied by 4 or negative 3 because the numbers are smaller there. And I'll just plug it into whichever one looks more friendly. And in this case, I believe the bottom equation looks a little bit easier to work with. So I'm going to plug 2 in for x into that bottom equation before I multiplied it through by negative 3. And so by plugging in 2 there, we'll get 3 times, in place of x, we plug in 2, plus 4y equals 26. Right? 3 times 2 is 6. You subtract the 6 to the other side. 26 minus 6 will be 20. And so we end up with 4y equals 20. Divide by 4 on both sides, you get y is equal to 5. Putting those two values together as an ordered pair, we end up with the solution 2 comma 5. That is the solution to this system of equations. All right. Okay, let's give this problem a try. We have 2/3 x plus 3/5 y equals negative 17. We also have 1/2 x minus 1/3 y equals negative 1. We're going to solve the system of equations using the elimination method, but that's going to be difficult to do with all those fractions in there. So our first task will be to get rid of all the fractions from both of our equations. And there's a trick that we have used before to accomplish this, which is to multiply both sides of the equation by the common denominator. So for the top equation, we have the denominators of 3 and 5. The common denominator there will be 15. For the bottom equation, we have the denominators of 2 and 3. The common denominator will be 6. And so we'll multiply the top equation by 15 to get rid of those fractions, and we'll multiply the bottom equation by 6 to get rid of those fractions. So when we do this, we have to distribute the 15 into the top equation. And so when the 15 gets multiplied to the 2/3, for example, the denominator will divide into that number, and the numerator will multiply to that number. So the way I like to think of it is the 3 divides into the 15, which leaves me with 5. That 5 will get multiplied by the 2 on top. So we get 5 times 2, which will be 10. And so we get 10x. Right, the x just gets copied down. The 15 gets multiplied to the 3/5. The same process happens. The denominator, 5, divides into the 15, which gives me 3. And then the numerator, 3, multiplies to that result. So we get 3 times 3, which gives me 9. So that's how we get 9y. The 15 also gets multiplied to the right-hand side of the equation, so that's where you get the negative 255. For the bottom equation, we'll multiply 6 to every term on the left and right-hand side. And when the 6 gets multiplied by the 1/2, the way I like to think of that is that multiplying by 1/2 is the same as dividing by 2. So we essentially are going to do 6 divided by 2 there, which gives me 3x. And when 6 gets multiplied to the 1/3, that's like dividing by 3. So we get 6 divided by 3, which gives me the 2y. And then the 6 gets multiplied to the right-hand side, which gives me the negative 6. So now we have our system of equations without any fractions. So this is very similar to the problems that we were looking at earlier. Next, we have to decide which variable we want to eliminate. And neither one of them are looking very promising. For example, when I look at x, I think, well, is there something I can multiply to the 3 to make it into a 10? So the x's will cancel out. And the answer is no, there's not an easy way to accomplish that. The same thing with the y variable. Is there anything I can multiply to the 2 to the equation on the bottom to make it into a 9? So the y variables will cancel out. And again, the answer is no, there's not an easy way to do that. So neither one of these variables are going to cooperate very nicely. But the one thing that is going in favor of the y variable is that they are already opposite signs. And that's a good thing, right? Because if the variables are going to cancel out, one needs to be positive and one needs to be negative. The y variables already have that going on. The x variables don't. So my choice here is going to be to try to eliminate the y variables. And because I can't just multiply something to the 2 to turn it into a 9, I'm going to have to multiply something to both of these equations and multiply the 2 and the 9 up to some common number. So I have to ask myself, what is a number that both the 9 and the 2 can be multiplied up to? And it's a very similar question as asking what is the common denominator between 9 and 2. And so the common denominator here, the common number that both 9 and 2 could be multiplied to, is 18. So we're going to make both of these numbers into an 18. The top number will become positive 18. We'll just leave it positive. The bottom one will become negative 18. So what do I multiply to the top equation to make that 9 into an 18? I multiply the top equation by 2. And what do I multiply to the bottom equation to make that number into an 18? I multiply it by 9. And so we'll multiply the top equation by 2. That'll give us an 18y on top. We'll multiply the bottom equation by 9. That'll give us negative 18y on the bottom. And then when I add those together, the y's will cancel out. So what are we going to get here? When we multiply 2 to the top equation, we have to distribute it. So we're going to end up with 20x. I have to erase what we started with originally, and so I have space here. We'll have 20x plus 18y equals negative 510 when we multiply 2 to the top equation. When we multiply 9 to the bottom equation, we're going to get 27x minus 18y equals negative 54. And now we're ready to add these two equations together because the y variables are ready to cancel out. So when I add these two equations together, I will get 47x. The y's will cancel out. So on the left-hand side, I just get 47x. On the right-hand side, I will get negative 564. And again, according to the addition principle, these two results have to be equal to each other. So we get 47x equals negative 564. I know this looks really scary, but it actually works out very nice. We divide both sides by 47, and we find x has to be equal to negative 12. All right, so now that we have our value for x, we want to find the corresponding value for y. We want to plug that into one of our original equations. But I wouldn't go back to the very, very original equations like we did in the previous examples because those had a bunch of fractions and I really don't want to deal with all those fractions. So I would plug this negative 12 back into either the set that we have on the screen right now or the set just previous to that where there were no fractions. So let's see what I decided to do here. So I guess I decided to use what I have on the screen already. This is not the best choice because again, these numbers are bigger than they really need to be, but it'll do the job. It'll tell us what the correct value for y is. So I'm going to plug x equals negative 12 into that bottom equation there. I'm sorry, I guess I tricked myself here. I forgot what I put. So remember that this bottom equation, 27x minus 18y equals negative 54, that originally came from the equation 3x minus 2y is equal to negative 6. So I am going back to the equations we had on the screen just prior. And we're going to plug negative 12 in for x into that equation before I multiply both sides by 9. So let's go ahead and do that. We'll get 3 times negative 12 equals negative 2, so not equals negative 2y, excuse me. Let's try that again. 3 times negative 12 minus 2y equals negative 6. We'll simplify this. We get negative 36 minus 2y equals negative 6. We add the 36 to the other side, and so we'll end up with negative 2y equals 30. And then we divide by negative 2 on both sides. And so our result here for y is negative 15. So putting those two together, we get the ordered pair negative 12 comma negative 15. That is our final answer. Okay, let's take a look at a word problem. The Serenity Yoga Center offered patrons who bought a 24-class pass either a free iPillow or a free yoga DVD. The center's cost for each iPillow was $10, and its cost for each DVD was $8. A total of 15 people took advantage of the offer. The center's total cost for the promotional items was $136. How many of each item did the patrons choose? Okay, so this word problem can be solved using a system of equations. A good indication of that is there are 2 unknown values that we're being asked to find. The number of iPillows that were given away and the number of DVDs. So we'll let a variable represent each one of those, and we're going to have 2 variables that we're going to be looking for. And in order to find a solution involving 2 variables, we will need 2 equations, and hence we'll have a system of equations. The 2 equations are going to be found from this information. The fact that a total of 15 people took advantage of the offer is going to give us 1 equation, and the fact that the total cost of the items was $136 will give us another equation. So we're going to need to use 2 variables. I typically like to use x and y, but you're more than welcome to use, P for pillow and D for DVD or something like that. And we need to have a clear sense of what these variables are going to represent for us. So oftentimes if I ask a student, well, what is x going to represent? They'll often just tell me something like this. They'll say x will be the pillows and y will be the DVDs. And if you let x represent just pillow and y represent DVD, you can run into some ambiguity problems when you go to set up the equations. So for example, the first equation we'll get from the fact that a total of 15 people took advantage of the offer, which means they gave away 15 of these items. So it makes sense to say the pillows plus the DVDs has to add up to 15 because the number of pillows they gave away plus the number of DVDs is equal to 15. The second equation is going to involve the total cost of $136. And again, we could say something like this. We could say, if we take the pillows plus the DVDs, that was $136 altogether. And because of the ambiguity in the variables and the way we're describing these equations, we're going to run into some trouble. So since x represents the number of pillows, not the number of pillows, excuse me, since x represents pillows and y represents DVDs, we could rewrite that first equation in orange like this. We could say, well, since x is pillows, we'll have x there for pillow, and we'll have y there for DVD, and if you add those 2 together, it has to add up to 15. But we could do the same thing for the second equation. Since x is just representing pillows and y is representing DVDs, we could rewrite the second equation as x plus y equals 136. Now when you go to solve this system of equations, x plus y equals 15 and x plus y equals 136, you'll run into a problem, and you'll find that there actually is no solution to that system of equations. And it's not because the word problem is ill-formed, it's because our equations are ill-formed. We're not being specific enough about what x and y are representing, and we're not being specific enough about the pillows and the DVDs and the 2 equations we have here in orange and blue. Variables have to represent numbers. They cannot represent objects. So to say that x is equal to pillows doesn't really make sense. So what about the pillows should x represent? What number regarding the pillows should x represent? And what number should y represent regarding the DVDs? The sensible thing to do here is to let x represent the number of pillows and to let y represent the number of DVDs. So let's go back and reevaluate our orange and our blue equation to see if x and y still make sense the way we're using them over there. So for the first equation, the total number that we're giving away, 15, it makes sense to say the number of pillows that were given away plus the number of DVDs that were given away equals 15. That equation still makes sense. And so we should still let X represent the number of pillows and Y represent the number of DVDs. And so the equation will remain X plus Y is equal to 15. But does it make sense for the bottom equation? Does it make sense to say that the number of pillows plus the number of DVDs equals $136? No, that doesn't make sense. Right, what we really want to have there is the cost of the pillows plus the cost of the DVDs equals $136. And so it doesn't make sense to have X plus Y equals 136 because X represents the number of pillows and Y represents the number of DVDs. So this equation doesn't make sense anymore. So we're going to cross that out. And instead, we should think of it this way. If we want the total cost of the pillows, we want to take the number of pillows that were given away times $10 for each pillow, right? Each pillow was $10 times the number of pillows that were given away will tell us how much the pillows cost. We do the same thing for the DVDs. If we take the fact that each DVD was $8 times the number of DVDs that were given away, that tells me the total cost of the DVDs. And so our second equation should look more like this. $10 times the number of pillows that were given away plus $8 times the number of DVDs that were given away, that adds up to $136 altogether. And again, X will represent the number of pillows, this part right here, and that will have to get multiplied by 10 in the equation. Y represents the number of DVDs, so we can use Y here, but then that gets multiplied by 8, and so our equation becomes 10Y, sorry I said the wrong thing, 10X plus 8Y equals 136. All right, so we let X represent the number of pillows, we let Y represent the number of DVDs, and so we get 10X plus 8Y equals 136. So there's our second equation. And now we have very well-defined variables, and we're using them exactly the same way in both equations. All right, so let's go ahead and rewrite our two equations that we have. We have X plus Y is equal to 15. We have 10X plus 8Y is equal to 36. Now that we have the equations set up properly, we just tackle this problem just like a system of equations. We don't have to worry now about what X is and what Y is. We just have two equations that we want to solve. Right, and so let's go ahead and get rid of this stuff over here. Well, let me jump ahead. Okay, so we'll get rid of this space over here so I have some space to work. To solve this system of equations, we could use the elimination method like we've done so far this section, but I think with this equation being so simple, X plus Y equals 15, it'll be easier to solve using the substitution method. So what I'll do is I'll take this top equation and solve it for Y by subtracting X to the other side. We get Y is equal to 15 minus X. And then I can substitute that into the bottom equation just like we learned in the previous section, 3.2. And so what we're going to end up getting here is 10X plus 8 times, instead of Y, we'll have 15 minus X, equals 136. And now that we've substituted into this equation, we can now solve for X. We'll first distribute the 8. And so we'll get 8 times 15, which is 120. 8 times X, which gives us 8X. We'll combine like terms. 10X minus 8X gives me 2X. Subtract the 120 to the other side, and we get 2X is equal to 16. Divide by 2 on both sides, we get X is equal to 8. So now we know what X is equal to. We need to find the corresponding value for Y. We do that by plugging it into this equation here. This would be the easiest place to do this. You could use the bottom equation, but it's just more work. So we'll use the top equation. We'll plug 8 in for X, and we'll get that Y is equal to 15 minus 8, which is 7. And so we get X is equal to 8, and Y is equal to 7. And what that tells me, now we need to go back to, okay, well, what does that tell me? Well, remember, X is the number of pillows. So that's how many pillows were given away, 8 pillows. And the number of DVDs that were given away is 7, right? So Y is equal to 7. That's the number of DVDs. So 8 pillows were given away, 7 DVDs were given away. And that is the final answer.